Guys, good morning to all of you. This is Maggi here, and now we are going to get discuss about the Doppler effect in the light. So let me discuss here. This is the Doppler effect in light. So simply we can say that it based on the relative motion between the source and observer, and source is just like and star, just like this is a star. Okay, star source, and it's seen by any observer on the earth. So observer. Okay, so this the simply we can say that the relative motion between the source and observer is known as Doppler effect in light, or simply we can say that whenever any source just like a star and any observer just like any person on the earth which are in relative motion, then change in frequency of the source or change in wavelength of the source is known as Doppler effect in light, and the change in this wavelength in both is known as Doppler displacement. So we can say that the relative motion between source and observer is Doppler effect in the light, or in other words we can say that whenever any source and any observer are in relative motion, then change in frequency or change in wavelength is known as Doppler effect in light, or change in wavelength is also known as Doppler displacement. Okay, so how can it is possible? So let me consider here, this is star which works as a source, and this is a person or a man which is standing on the earth, and the source seen by this person. Okay, so whenever this is the its original condition, and whenever the increment of the wavelength formed, okay, increment of the wavelength is formed. This is source S and this is observer O. When wavelength increases means ये हुआ wavelength increases, or increment in the wavelength be formed, then you know that the wavelength is greater for the red color. So whenever this position shifted towards the forward direction or in the red color side, or formed increment in the wavelength, then it is the known as red shift. जब रेड कलर की तरफ शिफ्ट होगा तो रेड शिफ्ट बोला जाएगा. एंड सिंपली व्हेनेवर द डिक्रीमेंट ऑफ वेवलेंथ बी फॉर्म. अब यहाँ पर क्या हुआ, ये पोजीशन इसकी विद द मेन पोजीशन कह सकते हैं, इट इज द मेन पोजीशन, और अब ये सोर्स की जो पोजीशन है इधर को शिफ्ट हो गई, इस साइड को. अभी किधर को थी, इधर को. अब इधर को जब शिफ्ट हो गई तो इसको क्या बोलेंगे, वेवलेंथ डिक्रीजेस और डिक्रीमेंट इन द वेवलेंथ. एंड you know that the least wavelength for the blue color, so simply this is known as the blue shift. Okay, so अब देखिएगा ये इसकी मेन पोजीशन थी, and we can say that this is the Doppler effect whenever the relative motion formed between the source and any observer. Okay, or in simple words we can say that whenever any source and any observer are in relative motion, then change in wavelength of the source is known as Doppler displacement, and it is also the known as Doppler effect in the light. Here this is the mean position, and whenever the wavelength increases or increment formed in the wavelength, or its the source shifted towards the rightward with respect to its mean position, then it is the known as redshift. And whenever decrement of the wavelength be formed, or this source shifted towards the back side or left side, okay, so here the wavelength decreases or decrement form of the wavelength, so this is known as the blue shift. Okay, and let me discuss here the Doppler displacement by the principle of relativity. Okay, so using principle of relativity so that is nu dash equals to nu root over 1 plus v by c upon 1 minus v by c. This is the relativity principle, where nu equals to c by lambda and nu dash equals to c by lambda dash. Nu is the frequency and lambda is the wavelength. Nu equals to frequency of source, or lambda equals to wavelength of source. Okay, in the same way nu dash equals to frequency of observer, or lambda dash equals to wavelength of observer. Okay, now putting this value in this first equation, this is first. Okay, so c by lambda dash equals to c by lambda 1 plus v by c power 1 by 2 upon 1 minus v by c power 1 by 2. Okay, so this is equals to lambda by lambda dash equals to 1 plus v by c power 1 by 2 upon 1 minus v by c power 1 by 2, और सिंपली लैम्डा डैश अपॉन लैम्डा, अगर हम इसको रिवर्स कर देंगे तो भी ये भी रिवर्स हो जाएगा, 1 माइनस वी बाई सी पावर 1 बाई 2 अपॉन 1 प्लस वी बाई सी पावर 1 बाई 2. अब इसको हम ऊपर लेकर के बाइनोमियल थ्योरम से एक्सपेंड कर देंगे. सो 1 माइनस वी बाई सी पावर 1 बाई 2 and 1 plus v by c power minus 1 by 2, and both be expanded by the binomial theorem, just like 1 plus x power n, that is 1 plus nx. जो भी साइन यहाँ है वो और जो पावर का मल्टीप्लाई है x के साथ मल्टीप्लाई हो जाएगा. सो लेमडा डैश बाय लेमडा 1 माइनस 1 बाई 2 v बाई c, और इसका हो जाएगा 1 प्लस माइनस 1 बाई 2 v बाई c. सो both are same, so it can also written as plus minus minus हो जाएगा. so 1 minus v by 2c whole square is equals to lambda dash upon lambda. Okay, so using here the principle of relativity, nu dash equals to nu root over 1 plus v by c upon 1 minus v by c. Nu is c by lambda, nu dash equals to c by lambda dash. Nu and nu dash are the frequencies of the source and observer, where lambda and lambda dash are the wavelength for the source and observer. So putting this value in this first equation, and we will obtain like this. Reverse this equation, so it will form like this, and both become in upward. So in this way it expand by the binomial theorem like this, so it will equals to 1 minus 1 by v by 2c whole square. So let me explain this square. Lambda dash by lambda equals to 1 plus v square by 4c square minus 2v by 2c. Okay, so 2 से 2 कैंसिल आउट हो जाएगा, lambda dash by lambda, और ये हायर टर्म है इसको हम नेग्लेक्ट कर देंगे. सो 1 माइनस v by c बचेगा केवल. सो lambda dash by lambda minus 1 equals to minus 1 by b by c. So lambda dash minus lambda by lambda equals to minus 1 by c. This is delta lambda equals to minus b by c into lambda, and this is known as Doppler displacement. Okay, and delta lambda is equals to lambda dash minus lambda. So here lambda dash by lambda is equals to 1 plus b by b square by 4c square minus 2b by 2c. A minus b whole square is equals to a square plus b square minus 2ab. This is the higher power term, so it will be negligible, and 1 minus v upon c, and 1 इधर कर दिया convert, so it will be equals to LCM ले लेंगे, lambda dash minus lambda by lambda is equals to minus 1 v by c, and lambda dash minus lambda is equals to delta lambda. This is delta lambda equals to lambda dash minus lambda. Okay, and this is known as Doppler displacement. So in this way we will solve the value of Doppler displacement. Thank you.